Hello, math students. Welcome back to our module called Area, Surface Area, and Volume Problems. This is lesson 3, and it is called Volume of Right Rectangular Prisms. The goal for today we will practice finding the volume of three-dimensional figures. The question that I want you to be thinking about is, what specific thing must you remember when working with volume? All right, things to remember. What is volume? If you were asked to describe what volume is to, let's say, a first grader, what would you say? What is volume? Well, what I would say is volume is the amount of space inside a three-dimensional figure. Okay, so that's what I would say volume is. Okay, so it's the amount of space inside a three-dimensional figure. So, for example, if I have a vase right here to put my flowers in, I would say that the volume is all of the space that is inside the vase. So we'll color here, right? And then if this was a see-through vase, it would be all of the space inside the vase. So if we're filling it up with water, all of this blue in here represents the volume. Okay, so the volume is the amount of space that's inside a 3D figure. Okay, how do you find volume of three-dimensional shape? Well, when you were a little bit younger in your schooling, maybe you had a math teacher who taught you that when you're talking about volume, you actually multiply three things together. And if I say this, some of you might go, oh yeah, I remember that. So you were probably taught that to find volume, you take the length times the width times the height. And that's how you find volume, because you have to have three lengths that are three dimensions that you multiply together to get the amount of space inside. And that is true. But now that you're getting older and you're getting into higher level math, we actually have a different way to find volume that is actually a lot easier if you can grasp what you're thinking about. And the way that you find volume when you get older, and it's kind of necessary to remember this, especially when you get into higher level math, is you have to understand that you're finding the area of whatever is the base of your 3D figure. So, so far, a lot of you have been working with boxes like Kleenex boxes, shoe boxes, Amazon boxes, and those are all called right rectangular prisms, which are very, very handy, but they're not very different or challenging. And using length times width times height, whenever you're working with a right rectangular prism, is very easy because you can find the length really easy, you can find the width very easy, and you can find the height very easy. Okay, so that's pretty simple. But what happens, kiddos, when you don't know what the length, the width, and the height is? Because let's say you have a different kind of prism. Let's say the kind of prism that you have is, how about a triangular prism? Okay, so your triangular prism kind of looks like a tent. So if you've ever gone camping, you've had a tent that looks like this. Well, this is called a triangular prism. And it's very different to look at because how do I know what the length is? How do I know what the width is? How do I know what the height is? So as you can see, yes, finding volume is length times width times height, but if you don't know what the length is, what the width is, and what the height is, it's very hard to find it. So the other way that we have learned how to find volume is to multiply the area of the base times the height. And so some of you are thinking, well, what in the world is area of the base? Well, the base is what tells you what kind of prism it is. So in this one, this is a triangular prism because it's built from a triangle. So we took the triangle and then we elongated it, or we extended it and made it longer. So the base of this prism right here, this is the base, okay, because it tells you what shape it is. The base tells you the shape, and then when it's elongated or stretched out, that is the height. So this right here is height. And when we're talking about height, we're talking about how tall. So if I was to take that tent and set it right on its door, you would tell me how tall into the sky that tent would go. So that's why we call it the height. If you're looking at this right rectangular prism, then this guy right here is your base, right? Because it's like a stick of butter. If we were to take this stick of butter and stand it up, okay, so the base is a rectangle, right? And then your height is how tall it would be if you stood it up on its end, okay? So this is another way to find volume, and I do have to have a conversation with you because volume means that you're multiplying three things together. Well, it still works because if you're finding the area of the base, how do you find area? On a triangle, you have to take base times height divided by 2. On a rectangle, you take length times width. So base is actually finding the area of whatever the base is first and then multiplying it by the height. So you're truly still multiplying three different dimensions together, okay? But you're breaking it up into parts. Okay, so finding volume, just to make sure you've got it. If it's a dimensional shape that you can look at and very easily find, then you could do length times width times height. However, if it is a dimensional figure that you can't easily find the length, the width, and the height, then you're going to do the base times the height. And the base means area of the base, okay? So if we fill out this little cheat sheet for us, it says 2 ways to find volume. One way to find volume is to take the length times the width times the height. Okay, that's one way. The other way to find it, after I just showed you what it looks like, is called area of the base. So you have to do big V times height. And the big V tells us, excuse me, as mathematicians, that you must find the area of it first. So big V means area of the base. That's what the big V means. And H means height. Okay? So those are the 2 ways of finding volume. You can either do length times width times height, if they're very easily labeled, or you can take the area of the base and then multiply it by the height. Okay? So those are the 2 ways. All right, so if we're looking at this rectangular prism that I drew, it says find the volume of the rectangular prism. Okay, so we can do it 2 ways, right? The 2 ways are you take the length times the width times the height. So we're saying the length is going to be 2, right? The width is going to be 5, and the height is going to be 8, okay? So that's one way to find it, right? So we would go 2 times 5 is 10, right? And then we would have to multiply 10 by 8, which gives me 80. And so our units of measures are centimeters, and we multiply 3 together, so it would be centimeters cubed, because that's what volume is multiplying 3 things together. Okay, so we know that this right here is 80 centimeters cubed. Now, if we didn't know what they were, then we could also do the area of the base. Remember, I colored in the base orange, so the base is a rectangle. So the first thing that you have to do is you have to take the area of the base for this one. So you would do area of a rectangle is length times width. So I'm going to take 2 times 5, which gives me 10. So 10 would go right here. And then the height, again, is 8, just like what we said. And then you multiply those 2 together, and you get 80 centimeters cubed. And the reason why it's still cubed is because the area of the base, you had to multiply 2 things together, and then you took that answer and multiplied it by one more thing, so you're actually still multiplying 3 things together. So either way, however you do it, length times width times height, or area of the base times height, you should get the exact same answer. Okay? Now, some of you are thinking, well, why do I have to do that? Again, the reason why you have to do that is because you are going to be given prisms that do not have your typical rectangular shape. For example, what if I gave you a trapezoidal prism? How many of you have ever seen a trapezoid? Well, a trapezoidal prism looks like this, right? Ooh, that's a really bad one. But you get the idea. So in order to find the volume of this, it kind of looks like one of those almond chocolates that you get from Hershey's. They're pretty yummy. You're going to have to find the area of the trapezoid, because that's your base, right? So you're going to have to find the area of a trapezoid, and then you're going to have to multiply that by the height, which is right here. So as you can see, length times width times height won't work for this, because in order to find the area of a trapezoid, you can't use length times width times height. You have to use the formula for a trapezoid, which we already learned. So you can see why area of the base times height is really a handy tool when we're trying to find volume. Okay? All right, so let's go back to our goal for today. Today we will practice finding the volume of three-dimensional figures, which we did. The question that I want you to think about was, what specific thing must you remember when working with volume? The answer to that question, and it's a must, it is an absolute must. The thing you must remember with volume is that your units of measure are cubed, because you multiplied three things together. The units of measure are cubed. So centimeters cubed, inches cubed, feet cubed, meters cubed, okay? So volume always deals with things being cubed, because you're multiplying three things together. All right? Okay, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.